we've got here a pretty interesting problem about a plane traveling against a headwind, and we have to figure out, accounting for the headwind, how is it going to land at the destination in precisely the right amount of time to stay on schedule. So this is actually a really common application. What we've got here is a bunch of information about, where the plane is flying. Okay, so you see I've circled here 83 miles, north 15.1 degrees west. That's the plane's target. And then we've got the wind, which is going at 31 miles per hour at a bearing of south 30 degrees east. That's the wind, and we want to make the trip in 40 minutes. So a bunch of information given to us here. And it's helpful when you have so much to try to just take a moment, figure out what we want. Okay, so look at what is asked for. The speed of the plane required and the bearing required. Okay, now speed is basically the magnitude of the plane's vector. I'm calling the plane's vector P. Bearing is basically the angle of P. It's the angle that plane vector is going to be making with the XY coordinate system. And then if I want P and theta, I'm going to need Px and Py. In other words, if I can get the components of this vector P, I'm done. I'll just turn those components into the magnitude and direction of the vector, and there we go. Now I've drawn here a little bit of a diagram. This always helps. If you think about what's going on here, I've got Kona, okay, got Kona down here, I've got Kahului up here, and we know that they are separated by 83 miles, and that's at a north by 15 degrees west heading. Okay, so that's the orange vector. That's the true map distance and direction between these two cities. Now the plane is going to be fighting this wind the whole way. The wind up here is going to be pushing it backwards. So the plane has to overshoot Kahului so that when you add the plane vector and the wind vector together, you get the target, the true vector. And that's what I've described in this equation right here, okay? So plane plus wind equals true, and I'm just reducing that to an equation, P plus W equals T in vector form. Well, let's start solving this. We have a few things that we were given back in those instructions, okay? First thing I'm going to focus on is the wind, right? So if I'm talking about the wind, I know that the magnitude of W equals 31. I was given that, okay? So there's no mystery there. The next thing I need to know is theta W, right? What angle is this W vector going at? Well, it said 30 degree north, what was it? It was south 30 degrees east, okay? Basically, this little 30 degrees thing over here, it's blowing southeast. Well, that's not the angle you want to use. You want to use an angle that goes all the way around from the start of the positive x-axis. Okay, so that's actually going to be 300 degrees. When you think about adding 3 quadrants of 90 degrees plus that 30 degrees. Great, so now we've got everything we need for the wind vector. Now let's talk about the true vector, the actual target of the plane. Well, the magnitude of the plane's speed is not given to us, but it's awfully close. We were told that we have to go 83 miles. Okay, and we have to do it in 40 minutes. So 40 minutes is not quite an hour, it's a little less than an hour. So I've got here 83 miles per almost an hour. And if you turn that into an actual wind speed of miles per hour, you get, you get 124.5 miles per hour when you punch that into a calculator. Okay, that's great. I should keep units consistent here, by the way. So wind speed is in miles per hour also. Now the direction of that plane heading, the true heading, is actually not too hard to calculate, right? This is just going to be 90 degrees plus 15.1 degrees. So that's going to be 105.1 degrees. Perfect. Now, using this equation, using this equation up here, let's go ahead and start forming some new equations. I'm going to say, and I'll just keep everything in one color, Px plus Wx equals Tx. Okay, well, let's use what we know. Wx is the x component of the W vector. That's, that's not an equal sign, that's a plus. So the x component of the W vector is 31 cosine 300 degrees. And that's going to be equal to the x component of the t vector. Well, that was 124.5 times the cosine of 105.1 degrees. Okay, so now all we have to do is solve for px, and we're good. I think this is a pretty simple calculator job. If you punch this in, remember we're in degrees here, we're not in radians, so keep track of that. You're going to get px equals negative 47.9328, and that's in units of miles per hour. So in other words, the plane has to be traveling to the left. Well, we kind of knew that already from the picture, but still good to have. Now, next equation, py, I keep saying py equals, py plus wy equals the true y heading. So, sub in what we know. The wind vector has a magnitude of 31, and its direction is 300 degrees. So, whoops, can you see what I did wrong there? We are using sine, okay, because this is the y component, the vertical component. So py plus 31 sine 300 equals, where were we here? 124.5 sine, this is the y component, of 105.1 degrees. That's the true vector. So if you solve this one for py, you're going to get py equals 147.0481. You'll notice I'm using a lot of decimals here. That is important because we are not done with the problem yet. We can do our rounding at the end, okay? So here's the two important pieces of information. I'm basically done with the problem now. I know the plane's velocity in x and y. That's this velocity and this velocity. I know those things now. And if I just put those together with a little Pythagorean, I can come up with the true plane speed and heading. I'm sorry, the intended plane speed and heading to get to its destination. So for this one, we just remember that the magnitude of a vector is equal to the square root of the squares of its components. So that's going to be equal to, if you plug in these numbers here, right, py, px, that's going to be equal to, let's see, what did I get? I got 154.66 miles per hour, okay? So that's one of the things we were looking for. That's how fast the plane has to fly. Now, in terms of the direction the plane has to aim itself, this is going to be the arctan. Hopefully you're familiar with this equation by now. The arctan of the y component divided by the x component. Remember, you have to know whether your calculator is talking about degrees or radians. You might be in radians, double check. The degrees are going to be more useful for us here. What I get from my calculator is negative 71.95 degrees. Well, that's great, but think about what that means for a moment. If I draw an XY grid right here, that's something like this, okay? That's exactly the wrong direction that my plane's going in. I'm supposed to be going northwest. This has me going southeast. Well, remember, calculators are idiots. They're just going to tell you whatever arctangent value is in those fourth and first quadrants, okay? If it's negative, it's going to be in quadrant 4. So this is where you have to say, I'm going up and to the left, not down and to the right. So you add 180 to this thing, plus 180 degrees. And that's going to give you the true answer. This is, the plane's going to be going 108.05 degrees. That's its heading, right off this way somewhere. Now, if you put that in as your answer, it's going to say you're wrong because it wants the answer as a bearing. So, in other words, north and how much west? This little part right here. This whole thing that I'm drawing, that's your 108.05 degrees. Well, you just subtract 90 off of that and you get your bearing. Okay, so this is going to turn into north 18.05 degrees west. And there you go, airplane pilot, you have gotten to your destination.